Continuing our discussion of algebra and linear algebra, now I want to talk about matrices and determinants. So a matrix, as defined in the reference handbook, is an ordered set of elements arranged in a rectangle of m rows and n columns and set off in brackets, as shown in the extract from the reference handbook here. And in this case, the first one here, the matrix A, has 3 rows and 2 columns, and B is 2 rows by 2 columns. And the number of manipulations that we can perform on matrices, for example, multiplying them together, and as stated here, for multiplication to be possible, the number of columns in the first matrix A must be equal to the number of rows in B. So in this example here, C is the product of the matrices A and B, and the general rule here is that the first element here, this element, is equal to A times H plus B times J, etc., for the other elements. And the second one here, this one, is A times I plus B times K, etc. are the rules for multiplying matrices together. Addition of matrices, shown here, is simpler, and for addition of matrices, the number of rows and columns in both matrices must, of course, be the same, and here we simply add the corresponding elements. So the first element here is just A plus G, etc. There are a couple of other things which are mentioned which probably won't arise, but the identity matrix is a square matrix, in other words, n by n, where all of the diagonal values are 1 and all of the other elements which are off diagonal are 0. To transpose a matrix, we simply reverse, the rows become columns and the columns become rows, and the transpose matrix we usually denote by A superscript T. And finally, we have the inverse of a matrix. A to the minus 1 is the adjoint of the matrix divided by the determinant of the matrix. But again, I give these definitions for completeness, but I doubt that they will arise in the actual exam. So let's do some examples. We have 2 matrices, A and B, which are given here. And the first question is, what is the sum of the 2 matrices? So to sum them up, we simply add up the corresponding elements. So the first element here is 2 plus 1. This element, 7, is 3 plus 4, etc. So here is the sum of those 2 matrices. Next, what is the product of the 2 matrices? So here we have the product, A multiplied by B, is 2, 3, 4, 1 multiplied by, etc. And to compute this, we multiply the elements of each row by the elements of the corresponding column in the second matrix. So in this case, the first element here is 2 times 1 plus 3 times 3 is this element. And the second element here is 2 times 4 plus 3 times 0. And similarly for the bottom row. So computing all those numbers out, the answer is 11, 8, 7, 16 is the product of those 2 matrices. Now, related to this are determinants, and a determinant is a scalar quantity which is computed from a square matrix. In other words, the number of rows and columns is the same. And the definitions and the computations from the handbook are given on the right-hand side here. So, for example, a determinant we write either this way, det of A, or A confined within 2 vertical lines. And the simplest case is a 2 by 2 matrix, A1, A2, B1, B2. And the value of the matrix is the cross products here, A1, B2 minus A2, B1 is the value of the determinant of that matrix, which is the equation given right here. For a third order determinant, or a 3 by 3 determinant of a matrix, A1, A2, A3, etc., is shown here, the answer is a little bit more complicated. The result is given here. And an easy way to compute the value of the determinant is to compute the values one at a time. So first of all, I take A1 here and cross out the row and column containing that. So I have A2 multiplied by B2C3 minus B3C2, which is the first term here. Next, I go to the coefficient A2, again cross out that row and column, and the signs alternate when I do this is plus, minus, plus. So this is going to be minus A2 multiplied by B1C3 minus B3C1, etc. And I could do that for the last one here. So that's a simpler way to remember and to compute determinants, and if you expand these out, I suggest you check that, you can show that those two equations are the same. So let's do a couple of examples on that. Firstly, the determinant of this 2 by 2 matrix is most nearly which of these alternatives? So this one is very simple. It's just 2 times 3 minus 4 times 1, which is equal to 2, so the answer is A. But a 3 by 3 matrix is a little bit more complicated, and we're given this determinant, which the determinant of the matrix is most nearly which of these 4 answers. So again, I follow the rule which I just gave you. Starting off with the number 2, I cross out the column and the row, and that is equal to 2 times 0 times 1 minus 2 times 4. Then I go to the column 3, cross out 3 and the row 2, and that is equal to minus, because the sign alternates, 3 times 1 times 1 minus 2 times 3. And finally, the column with 1 and the row with 1, cross that out, that is plus, because the sign alternates again, 1 times 4 minus 0 times 3 is equal to 3, and so the answer is C. And this concludes our discussion of matrices and determinants.